Hello, hi everyone. Welcome to the Student Brand. So this is what Shiva sir. Today topic is magnetic effects of electric current. Magnetic effects of electric current. So be ready for it. Magnetic effects of electric current. In this topic. So in magnetic effects of electric current, mainly we discuss about magnetic field when the current is passing through the conductor. When the current is passing through the conductor, how the magnetic field will be created, in which direction it will be there. So with what tool we will identify. That is one thing. And magnetic field, properties of the magnetic field. Properties of the magnetic field discuss like attraction, repulsion, and if you are suspending freely, how the magnetic field will be there. And next one more we'll discuss about current carrying conductor. So current carrying straight conductor will discuss. And so one more point is loop also will discuss. Loop we will discuss about loop. Current carrying current passing through the loop. And and one more thing we'll discuss about current carrying through the loop and current carrying through the solenoid, and that is about solenoid and a magnetic field, bar magnetic field, and solenoid. Nandinija, hi. So welcome to the class. So like this, we'll discuss. And one more point is the difference between bar magnetic field and solenoid. And one more point, we'll discuss about Fleming left-hand rule, and current carrying conductor placed in the magnetic field experience force. That also we'll discuss. Current carrying conductor placed in the magnetic field experience force. Current carrying conductor placed in the magnetic field experience the force. That also we'll discuss, right? So related to these points, we'll discuss about we'll discuss in the magnetic effects of electric current. The topic itself gives the meaning magnetic effects of electric current, means by passing the current through the conductor, so the conductor exhibit, the conductor produce, or it act as a magnet. It act as a magnet. We will discuss all those points, right? Yes. Now, so introduction. So one more new song I just now. Anyway, already I created that one, so I wrote that song. So just for remembering sake, I'll be singing. Okay, so whenever you are listening these songs, so immediately the concept should remember. Okay, so that is myopia, 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 myopia. Near distance we can see her, far distance we can see her. Myopia, myopia, myopia. For that correction we are using Bro, what bro? For that correction, we are using concave lenso, concave lenso, concave lenso, concave lenso. Hypermetropia, 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 hypermetropia. For a distance, we can see. Near distance, we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using, we are using, we are using convex lenser, convex lenser, convex lenser, convex lenser. Hypermetropia, convex lenser, hypermetropia, convex lenser, hypermetropia, convex lenser, hypermetropia, convex lenser, hypermetropia, convex lenser. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole. Distance are positive along the instances, distance are negative opposite to instances, distance are positive above the principal axis, distance are negative below the principal axis. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole. Distance are positive along the instantaneous, distance are negative opposite to instantaneous, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, New Cartesian sign convention. Say with me, learn with me, sing with me. Dispersion, dispersion. Say with me, learn with me, sing with me. Dispersion, 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 dispersion. Splitting a white light into 7 colors is known as dispersion. Dispersion. Band of colors is known as spectrum. Band of colors is known as spectrum. Refraction takes place by atmosphere is known as atmospheric refraction. Atmospheric refraction. The process of re-emission of light in all directions with a different intensity is known as scattering of light. Scattering of light. Scattering of light. Dispersion, dispersion. Say with me, learn with me, sing with me. Dispersion, 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 dispersion. Okay. So, welcome to the class, everybody. Welcome to the class. So now we are going to discuss about magnetic effects of electric current. Magnetic effects of electric current. Magnetic effects of electric current. So now, first of all, we'll discuss about. First of all, we'll discuss magnetic properties. Normally, initial days, so in olden days, okay. So people are moving on the sea. They are in all the directions. Water is there. They couldn't able to find in which direction they have to go. So that time they're using this magnet, the substance which attract the magnetic materials, which influence the presence of other magnetic materials. So the substance which attract the magnetic material, that is magnet. So the natural magnet is magnetite. Natural magnet is magnetite. So natural magnet is magnetite. Magnetite. So that is also called lodestone. That is also called a lodestone. So why we are calling it as a lodestone? So as I said, people are moving on the sea, so they couldn't able to identify. They couldn't able to identify. So they couldn't able to identify. Yes, very good. Natural magnet is magnetite. They couldn't able to identify in which direction they have to go. So for that, they use the stone, the substance which attract the magnetic materials. So if you suspend it, always it shows north and south direction. Magnetite is a natural magnet. Now magnetite is a natural magnet. Okay. So a lodestone. So lodestone because it is leading them. It is leading them. Okay, definitely. Sure, we can. Okay, so the people, those who want, okay, so those who want to move from one place to another place, they will use this stone. They will use this stone, lodestone. This is also called because they are this stone is leading them. This stone is leading them. So that is also called lodestone. That is also called lodestone, right? Yes. Now we can see magnetic effects of electric current. Magnetic effects of magnetic effects of effects of effects of electric current. Magnetic effects of electric current. Okay, so CBSE grade 10, CBSE, CBSE grade 10, CBSE grade 10 physics, grade 10 physics. Okay, CBSE grade 10 physics. So that is about yeah, of course I will teach. So you can contact this number 9849812804. So this is my number. So you can contact to this number. So we will discuss further. Abdul, just contact to this number. So we'll discuss further details. Okay. So magnetic effects of electric current we are discussing. Magnetic effects of electric current. Okay. So magnet already said. So already said the material which attract the magnetic material, that is called natural magnet. Okay. So it occurs from earth crust, which occurs from earth crust. Okay. So that is about natural magnet we are discussing. Okay. First of all, magnet has two properties: attractive property or directive property. So if you are taking, so I'm considering the artificial magnets are there. The natural magnet is there. Natural magnet is magnetic. Artificial magnets are bar magnet, U-shaped magnet, dumbbell-shaped magnet, horseshoe magnets. So spherical magnet, like the different types of magnets are there. Different kinds of magnets are different types are there. So those are artificial magnets. Artificial magnets are man-made magnets. Artificial magnets are man-made magnets. Man-made magnets. So we are discussing now the properties of the magnet. The properties of the magnet. One you can see, I'm taking. So bar magnet, if you are taking, this is a bar magnet I'm considering. This is a bar magnet. So magnet has two poles. First one is magnet has two poles. Magnet has two poles. So two poles have equal strength. Two poles have equal strength. So if you suspend the magnet, if you drop the magnet into the sand, what happens? So the magnetic materials will attract at the ends of the magnet. Okay. So equally the proper. So the strength will be equal at the poles. The strength will be equal at the poles. Okay. So here and here. So equal at the poles. It will attract the magnetic material. If you drop the magnet, if you drop this one bar magnet, if you drop into the sand, the magnetic materials will attract at the poles. Equally, equal strength will be there. Okay. So than in the middle. So at the middle it will be less. at the middle it will be less, at the middle it will be less, at the ends it will be more. So equally the magnet will attract the magnetic materials, I hope it is very clear to you all, right? So if you are taking north pole, north pole will repel. First one, north pole will repel. North pole, south pole will attract. North pole, south pole will attract. South pole, north pole will attract. South pole, north pole will attract. So south pole will repel. South pole will repel. So these two repel. So by we can understand two dissimilar poles. Dissimilar poles will attract. Two similar poles will repel. So I'm taking this a repel. Okay. So attract. I'm taking. So here also repel. Two dissimilar poles will attract, two similar poles will repel. Two dissimilar poles will attract, two dissimilar means north north attract each other. Two similar poles north south will repel each other, will repel each other. Okay, so this about. And one more thing, one more property, if you suspend the magnet, always it shows north and south direction. If you suspend the magnet, always it shows north and south direction. Always it shows the north and south direction. So if you are taking the magnet, and if you hang it, if you suspend it, if you are taking the stand and suspend it, okay, so if you are suspending it, always shows north and south direction. This is north, south, east and west. Okay, it always shows north and south direction. So it's not, so it won't be showing exactly vertical. So with inclination it will be showing. Okay, so with inclination it will be showing somewhat like this. Okay, exactly it won't show 100% vertical. So with inclination it will be showing, right? Yes. So that is about okay, if you suspend the magnet, always shows north and south direction. Okay, so next one, coming to the bar magnet, magnetic field will discuss. Bar magnet, magnetic field will discuss. I am taking the bar magnet is like this. I am taking the bar magnet. Okay, so this is a bar magnet. Bar magnet I am considering. Bar magnet. If you are taking the bar magnet like this, okay. So I am taking here. This is north and this one is south. Okay, as I said, magnetic poles have equal strength. So equally the poles will attract the magnetic materials. And one more thing, around the magnet, field will be there in the form of field lines. So what is exactly magnetic field? First one we have to discuss about what is magnetic field. Magnetic field is nothing but the region around the magnet, in the region around the magnet in which magnetic force exert. What exactly the magnetic field? The region around the magnet, you can observe. So this is the magnet, around the magnet, the field will be there. So the field will be there. So around the magnet, the magnetic field will be there. Okay, the magnet will attract the magnetic material. Around the magnet. Okay, how the magnetic field will be there? The magnetic field will be in the form of magnetic field lines. Hi Shivani, welcome to the class. The magnetic field will be in the form of magnetic field lines. Tavinesh, hi. Tavinesh, hi. So the magnetic field will be in the form of field lines. So how the field will be? As I said, so around the magnet, the field will be there. Around the magnet, the field will be there. So the field will be in the form of field lines. Okay. How the field lines will be there? So if you are taking the certain region only, if you are taking this is a magnet and this one is a magnet. Okay. So this is a magnet and this is a magnet. So if you at certain distance only, this magnet will attract this magnet. Okay, at certain distance only it will attract. So beyond, if you are moving away from it, it won't attract. Okay, so this magnet will not attract this magnet. Okay, because at certain region only, At certain region only this magnet. So at certain region only this magnet will attract this magnet, right? Okay, so this magnet will attract this magnet. Okay, so magnet A I'm considering. So instead of this one, that one like that, I'm taking magnet A and magnet B. So magnet A will attract magnet B within certain range only. It will attract. So the field range will be certain region only. So beyond the point it won't attract. Beyond the point it won't attract, right? Beyond the point it won't attract. So if you take near to the if you bring this magnet near to the magnet, okay, certain region, certain distance, then it will attract. So as you move away from it, the magnetic field decreases. It won't attract. The region around the magnet in which the magnetic force exerts, the region around the magnet in which the magnetic force exerts, or the magnetic force acts, is called magnetic field. The region around the magnet in which the magnetic force exerts, is called magnetic field. The magnetic field will be in the form of field lines. So I'm considering here, I'm taking here. So the magnetic field start from north. And reaches to the south pole. Magnetic field start from north and reaches to south pole. Okay. So if you are considering here, like this, okay, magnetic field will be starting from north or emerging out from the north, and merging at south. Okay, so emerging out from the north and merging at the south pole. Okay, so as I said, the direction of the magnetic field will be from north to south. How can we identify the direction of the magnetic field? So the direction of the magnetic field, one activity is there. The activities. So general processes, normal processes. If you place any magnetic material near around the magnet, it will attract, right? Yes, sir. So compass will be there. Compass is there. Compass also, inside of it, a small magnetic needle is there. Compass consists of small magnetic needle present inside of it. So inside of the compass is also a small magnetic needle. Always it shows north and south direction. So if you are taking here, so I'm taking the bar magnet here. This is the north and this one is south. So you have to place the compass. Near to this one. If you place the compass here, it will show. So this side is north, this side is south. Yes or no? This will attract. Again you have to replace another position. Again it shows like this. Again another position. Again it will show. Again another position like this. So if you keep on changing the compass, automatically the direction will be shown in this direction from north to south. So this is a free north pole, without any influence, without any external force. So automatically south will attract to the north will move towards that one. That is the reason outside of the bar magnet, the magnetic field will be from north to south. Outside of the bar magnet is, so the magnetic field will be from north to south. Outside of the bar magnet is, the magnetic field will be from north to south. Outside of the bar magnet is, the magnetic field will be from north to south. Inside of the bar magnet is, the magnetic field will be from south to north. Each and every time you have to place the compass. So you have to move the position to the next position, and mark the position. If you mark the position and join at the end, if you're joining at the end, so the direction will be showing like this. So this is the free north pole of the magnet. Okay, free north pole of the magnet. So the direction of the magnetic field from north to south will be shown like this. Okay, so this is the free north pole of the bar magnet. Outside only. Outside means outside of the bar magnet, the magnetic field is north to south. Whereas inside of the bar magnet is, the magnetic field will be from south to north. Very, very important. Outside. So the magnetic will be, around the magnet. Learning is a continuous process. So our channel name is Student the Brand. Student the Brand in the sense, always, always say, always be as a learner. Okay, so that's why. To become a brand, if you want to become a brand, you must learn. You must learn the knowledge. Okay, that's enough. So here I'm considering north to south, north to south. So the magnetic field will be from outside of the bar magnet. Outside of the bar magnet is north to south. Inside of the bar magnet is south to north. South to north. I hope it is very clear to you all. So outside is bar magnet is magnetic field is north to south. Inside of the bar magnet is magnetic field will be south to north. Okay. This is about magnetic field and magnetic field lines, magnetic field and magnetic field lines. Okay, now we can see one more. So this is about magnetic field, already we discussed. This is about magnetic field. Understood? The magnetic field lines from north to south and south to north. Okay, and so one more point, I will how to draw the diagram. How to draw this magnetic field diagram. So I will draw. So you can see, you can take either 5, 7, 9. I refer. Either you can take 7, 9, 9, 7, 5 lines, 7 lines, and 9 lines. Okay, if you take these 3, 5, 7, 9 lines, then how the diagram will be there? I will show you. So 5 lines if you are taking, how the diagram. 7 lines if you take, how the diagram. 9 lines if you take, how the diagram I will draw. Okay, so first you are taking this is a bar magnet. So drawing the diagram. So in easy way. So this is the north and this is south. As I said, 5 lines. First 5 lines. 5 lines diagram. If you are taking 5 lines, okay. Anyway, one line it will go up. One line it will be up. One line it will be up. One line it will be middle. One line it will be like this. So you can take one more. So one more line also you can take. One if you are taking, it won't be good. So at least minimum 2 you have to draw. Okay, so if you want to draw a diagram like this. This is the 5 lines diagram. Okay, so magnetic field lines. Yeah, that is correct. So, Shakib, very good, correct only. So at any point, if you draw tangent to the curve, tangent to the magnetic field line at this point, if you draw the tangent here, if you draw the tangent along this direction, the magnetic field will be there at that point only. At that point, see here you can see. So you know velocity, distance, displacement. Velocity keep on changes because direction changes here also. So velocity of it will be at the point, it will be keep on changes, right? So in a circular motion, how the velocity changes here also. So direction changes, the magnetic field changes at a particular point. Okay, if you draw the tangent, very good. Sakib, very good, correct only. If you draw the tangent at particular point, so that gives the direction of the magnetic field at that point. At that point only the magnetic field direction. At that point, magnetic field direction we can identify by drawing the tangent to the magnetic field line. Okay, done. So now here I already said, so 5 lines you are taking. This is the 5 lines I'm taking. 5 lines diagram and 7 lines. 7 lines also I'll draw. See which one is better. You can decide. So then you can draw to get appearance is very very important diagram. So I'm taking north to south. So exactly middle line you have to draw the directions. Exactly here you have to draw the lines like this I'm taking. And here also you have to draw the lines. You have to direction must be shown here outside. So at the north pole, outside means emerging out. At the south pole it must be merging out, merging in. Okay, merging inside like that. So directions must be here. So directions you have to take. One is at the pole, another one here also in middle you have to take, and third one here. Then the diagram it looks very clear, neat, and X, and at the same time professional way. And coming to the 7 lines diagram. 7 lines diagram. Okay, 7 lines also will draw. So north, and I'm considering south. So 7 lines means we can take 2 lines up, 2 lines up, 1, 2. So like this, and here. Okay, like this. So 3 in middle. So 2 above, 2 below. Okay, direction as I said, compulsory you have to take the direction. Outside emerging out, emerging out, emerging out, emerging out, emerging out, emerging out, emerging. 1. So exactly middle. 1, 2, here, 2 direct. So here, second. And third one merging in. So this is the 7 lines. Coming to the 9 lines. 9 lines you can take. 9 lines diagram also I'll draw. Just check once. 9 lines diagram. So this is north. This is south. 1, 2, 3. Okay, here below also. 1, 2, and 3. And middle. 1, 2. Middle you can draw. 1, 2, 3. Okay, so 3 lines. 3 lines. So you can draw either emerging out, 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 emerging out. So in middle exactly here. So straight you have to draw like this. Okay, and here I am merging in. Okay, so as I said here first at the poles you have to mention the directions at the poles, and the second one in middle, third one here. So every time if you mention like this, every time if you are mentioning like this, clear, so it looks good. It looks good. Any lines you can select. Either you can take 5 lines, either you can take 7 lines, either you can take 9 lines. That is your choice. 9 lines. Okay, so 9 lines. 9 magnetic field lines. 9 magnetic field lines. Okay, so which one is preferable? Which one looks good? Which one looks good? You can select. You can select and draw in the exam. Okay, look at once. Look at once. Which diagram is good? Which diagram is good? That is your choice. You can select. You can select. You can select diagram. Which one is preferable to you? Or which lines are better to you? So I prefer, if you draw the neat diagram, I prefer 9 lines. Okay, so 9 lines. So it is very simple. It is okay, good. So this, if you draw in a neat way, better way, so still more. Okay, so 3 lines above, 3 lines below, middle 3 lines. So so my choice is 9 lines. So your choice and your choice according to your selection, according to your choice, you can select any one diagram and you can draw in the diagram. So you can draw in the exam. In the exam you can draw. Okay. So that is your choice. Okay. So lines are important. Lines are important. How you are taking. So however you wish, if you take and draw, we won't get it proper diagram. You won't get it proper diagram. Definitely this question will give for a 3 marks. 3 marks question in the exam, board exam. Okay. So first one you are saying. Properties of the lines. Properties of the line. First property is, so magnetic field emerge from north and reaches to south. Emerge from north and reaches to south. Magnetic field lines outside of the bar magnet. Outside of the bar magnet, magnetic field lines emerge from north and reaches to south. Emerge from north, reaches to south. And inside of the bar magnet is south to north. Outside. This is the outside of the bar magnet. Outside of the bar magnet, keep in mind, outside of the bar magnet, outside. So whereas inside if you are taking, inside of the bar magnet is south to north, south to north. So like this, inside of the bar magnet is, so I'm taking here, inside is south to north, inside is south to north, inside is south to north, like this, inside south to north. So magnetic field outside the bar magnet is north to south, inside of bar magnet is south to north, the magnetic field lines. Okay. So coming to the third one, these magnetic field lines are closed loops. Magnetic field lines are closed loops. Magnetic field lines are closed loops. Closed loops. Okay. So here edge emerge out from north reaches to south. Emerge out from north reaches to south. Okay, here also see. So you should not, as I said, closed loops, you can draw upper portion and lower portion. You should not draw the like this. Okay, that is wrong. So you must draw like that only. Okay, direction also very, very important. Direction also very, very important. Okay, so keep in mind that one. Direction also very, very important. Direction also very, very important. So make sure that you are drawing this one. Make sure that you are drawing this one. So those who want some more content, you can check my channel. So there are many videos are there. You can go to the playlist. So light reflection, refraction, in the playlist there are many videos. There are bunch of videos are there. And NEET students, those are studying, new students, okay, those are aiming for a NEET and JEE also, problems are available. So problems videos also are did. And you can check the playlist. There are many videos I did. And there are many experiments also. This whatever you are seeing, this is one of them. There are many experiments, many activities are there related to physics. You can check my channel, watch the videos, watch the content, and you can decide, okay, how the best, how it is, how it will be. Okay, come to the next one. And this is about a bar magnet, magnetic field. Okay, I said 3 points. Point number one is outside of the bar magnet is magnetic field is north to south. Inside of the bar magnet is magnetic field is south to north. Outside of the bar magnet is magnetic field is north to south. Inside of bar magnet is south to north. And third one, it is also, this magnetic field lines are closed loops. This magnetic field lines are closed loops. This magnetic field lines are closed loops. Coming to the fourth one. So fourth diagram represents. So fourth one is. So these magnetic field lines never intersect. Magnetic field lines never intersect. So never intersect. As I said, compass. If you are suspending the compass freely, compass always shows north and south direction. Compass always shows north and south direction, right? Compass always shows north and south direction. So if the lines are intersecting, as I said, so if you are taking like this direction, as second said, yes, he only said direction of the magnetic field at the point. Okay. So if you are drawing the line at this point, okay. At a time, it shows compass shows only one direction. So it won't show many directions, right? It is not possible. So if the lines intersecting at the point of intersection, so if the lines are intersecting at the point of intersection, compass should show two directions. Where it is not possible. Compass only shows one direction at a time. So it does not show two directions. It does not show two directions. At a time, the compass should show only one direction. So I'm considering here, so you can see, outside of the bar magnetic field is north to south. Inside of the bar magnetic field is south to north. Outside of the bar magnetic field is north to south. Inside of the bar magnetic field south to north. And these magnetic field lines are closed loops. Very, very important 3 marks question. So these properties will come for 3 marks. Properties of magnetic field lines. Properties of magnetic field lines. Magnetic field lines will come for 3 marks. Very, very important 3 marks question. Okay. Even 1 mark also they will give. Either 3 marks they will give, 1 mark they will give. Okay, in exam. So MCQ's point of view, very, very important. Yeah, MCQ's point of view, very, very important. MCQ's point of view, very, 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 very important. MCQ's point of view, very important. I'm saying. So once again, I'll explain. Listen carefully. Once again, I'll explain. Listen carefully. So outside of the bar magnet is magnetic field will be north to south. Outside of the bar magnet is magnetic field is north to south. Inside of bar magnet is magnetic field is south to north. So these are closed loops. Magnetic field lines are closed loops. Magnetic field lines are closed loops. So these field lines never intersect. These field lines never intersect. If these field lines intersect, so compass should show at a time two directions. Where it is not possible, right? Compass will show at a time only one direction. Compass will show at a time only one direction. So it does not show two directions at a time. Okay, so that's why we are taking. That's why these field lines never intersect. Never intersect. Very, very important for 3 marks. And also I said you can select any lines 5, 7, 9. So my preferred diagram is 9 lines. So I hope it will be good. It will be good. A 3 marks question. So properties of magnetic field lines will come for 3 marks in board exam. So UMA B. So 3 marks will come. Question, very, very important. There is three property, outside, inside, and closed loops property. Magnetic field lines does not intersect. Okay, if it is intersect, so compass should show two direction. So sometimes alone this question will come for 1 mark also in MCQs. So if the magnetic field lines intersect at a point of intersection, compass will show two directions or one direction. So compass should show two direction, but it's not possible. So that's why it won't intersect. These lines will not intersect, right? So that's enough. That is about this question. Very, very important. Make sure that you are learning this one. And bar magnet and magnetic field. Even if you suspend the bar magnet also, it always shows north and south direction. North and south direction. I hope it is very clear to you. Next one, we are going to the one more concept. Hans Christian Ørsted is given the relation. Hans Christian Ørsted given the relation between electricity and magnetism. Electricity, Hans Christian Ørsted, scientist name. Okay, so he given the relation between electricity and magnetism. Suddenly he discovered that say current carrying conductor place. Okay, compass is placed nearby current carrying conductor. Suddenly gets deflected. So it's got deflected already. Okay, deflection is shown. Deflection is shown. So once again, so compass. A compass is placed. For 5 marks, only one question will come. That is uh, normally current carrying conductor placed in the magnetic field. Current carrying conductor placed in the magnetic field. Experience force. Current carrying conductor placed in the magnetic field. Experience force. That question will come. Okay. So that I will explain. And that is end of the topic. That is only end. So that question will come. Once it comes, I will explain. Okay. Now we are going to the one more. That is. So I am taking this one. Current carrying conductor. So this is a current carrying conductor like this. So straight conductor also. So it is also current carrying straight conductor. Current carrying straight conductor. Okay, like this I'm considering. This is the example also we can take. So I'm taking this one. A thick wire also, thick copper wire also you can consider. Thick copper wire. So current is passing through it. Current is passing through it. So this is the rheostat. Rheostat without changing the potential difference. Without changing the potential difference. Can we use Fleming's left hand rule? Fleming's left hand rule. Okay. So current, magnetic field, and force. Here force is not required. No. Where is the force? What you are find? What is the need of that? Sravia user ID. Fleming left hand rule, yes. So that is in a current carrying conductor placed in the magnetic field experience force. That case we can use Fleming left hand rule. Very good. Yes, correct. You are saying to that one. So yes, correct. Current carrying conductor placed in the magnetic field experience the force by using Fleming left hand rule. Fleming left hand rule you can see. Fleming left hand rule. So magnetic field, current, and thumb represent the force acting on the conductor. Force acting on the conductor. By using Fleming left hand rule, we can identify in which direction the force will act on the conductor. Yes, very good, Sravya. Correct one. So now you are considering here. I am taking ammeter. I am taking, and so battery. So battery I am considering. Switch I am considering like this. Okay, so instead of that we can take switch here. We can consider so switch here I am taking here. So current is passing like this. So I am taking the current direction like this. So close it switch. Current is passing through the straight conductor. Okay, thick copper wire we can consider. So then we are taking like this. So I'm considering like this. So cardboard I placed. Okay. So actually, we know electromagnetism. So in a lower classes, we did one activity, that is, so take the copper wire. So wound around the conductor, take the copper wire, wound around the conductor, take the copper wire, wound around the conductor. Okay, so iron nail we can take. Suppose iron nail you can consider iron nail. Iron nail you are considering iron nail. So this is iron nail. Okay. So if you take the copper wire and wound around it and connect to the battery connect to the battery. Okay, so current will pass, then it act as a magnet. So it attract the magnetic materials. So this will act as a magnet, it will attract the magnetic materials. Same thing. So here it is called electromagnet. Here I'm considering the electromagnet. Okay, so this I'm considering as electromagnet. Here also, if the current is passing through the conductor, it act as a magnet. So take the cardboard. Actually we have to place the paper, so in such a way that, so paper we have to take. Paper I will explain just once. See. Okay, so I'm considering here. So this I am taking, this is a white paper I am considering. This is a white paper if you consider. Okay, so yes, I'm considering now. So I'll show you how you are doing, how you are taking this paper and like this. So this is the cardboard. If suppose if you are taking this is a current carrying conductor like this. So like this if you consider, so the current is passing through it. Okay, so this direction current is passing. So this is the cardboard I am taking. Okay, this is a, suppose if you take this a cardboard. Okay, so cardboard I am taking. So this is a cardboard. Okay, so if you sprinkle the iron particles over it, okay, around it, current is passing, as I said, current is passing like this. Current is passing. If you sprinkle the iron particles like this, what happens? Around this conductor, the iron particles will be there. Around this conductor, the iron particles will be there. Yes or no? So current is moving. So current is moving like this. Okay, so according to that one, if you are taking like this, current is passing downward direction. So I'm taking this diagram only. So current is passing downward direction. So we can consider like this. Okay, so in this direction the current is passing. Downward direction the current is passing. I is passing like this. Here also you are taking the current direction downward direction. Okay, so we'll use. Okay. Okay, so around this one magnetic field will be created, right? Around this one magnetic field will be created. Right? The magnetic field will be around the conductor in the form of concentric circles. So around this conductor, Around this conductor, this is the conductor I'm taking. If you sprinkle the iron particles, if you sprinkle the iron particles, if you sprinkle the iron particle, if you sprinkle around it, okay, around it the magnetic field lines will be there. So magnetic field lines are there. So the iron fillings will be arranged. The iron fillings will be arranged in the form of concentric circle. Concentric circles means taking as a center and making the circles around it. Okay. So with the help of this conductor, so making the conductor as a center, and forming the concentric circles around it. Will the concentric circle shows the direction of the magnetic field? Yes, absolutely. Direction of magnetic field. Yes. How to find out the direction of magnetic field? I will discuss. To find the direction of the magnetic field, one rule we will use. That rule is right hand thumb rule. Right hand thumb rule. So that I will show you. Okay. So here I am taking here. Current is passing. So around this one, if you sprinkle the iron particles, iron particle you are sprinkling. Okay. So around it, magnetic field, concentric circles will form. Magnetic field only. Magnetic field will in the form of concentric circles. Magnetic field will be in the form of concentric circles around the conductor. Right? Yes. So now you can consider. Now you are considering. Okay. So how to find out? See, by using compass, around this one. So I hope you got the clarity. So around this one, the magnetic field lines will form in the form of concentric circles. Okay. So around this one. Okay. So current is passing downward direction. Magnetic field will be there. So if you place the compass here, so then we can identify whether magnetic field is there or not. Whether magnetic field is there or not. Okay. And Pranay Kumar, hi. So magnetic field is there or not, we can identify. So here you are taking. So I will tell how, in which direction the magnetic field is there. So how it will be. If you are taking like this, so current is passing through the straight conductor by using right hand thumb rule. So thumb is showing along the current direction. Thumb is showing along the current direction. Curly fingers, folding fingers. Thumb showing along the current direction. Curly fingers, folding fingers. Folding finger represent the magnetic field direction. Okay, magnetic field direction. Right hand thumb rule will use. So along the direction of the current, so we will place the thumb. So along the magnetic field, we will use curly finger. Curly finger shows the along the magnetic field direction. So now you can see current is passing downward direction. So magnetic field will be low. So like this. Now we can observe in which direction it's moving. So if you are taking north and south and east and west, so I am taking this is north and south, east and west. Okay. So we can show like this. Direction will be shown like this. Understood? I hope it is very clear. So if current is moving downward direction, the magnetic field will be from east to west. So suppose here, if you take here, so in this direction, east to west, magnetic field east to west. So upper direction, if you take north to south. Okay. So along with the direction of the, so if you are taking like this, thumb showing downward direction, curly finger showing the magnetic field. Curly finger shows the magnetic field. Can you also say anti-clockwise or clockwise? Yes, that also we can say. Now you can see, I am taking this one. So clockwise direction, anti-clockwise direction. So here, if you see, watch. Normally, this is a clockwise direction. If the magnetic field moves along this direction, that is a clockwise direction. So opposite direction is anti-clockwise. Clockwise, anti-clockwise. Okay, anti-clockwise. Okay, we can say like this with the help of. Now, the magnetic field will be in the form of magnetic field will be in the form of clockwise direction. Clockwise direction. If the current is moving downward direction, if the current is moving downward direction, if the current is moving downward direction, the magnetic field will be clockwise. If the current is moving downward direction, the magnetic field will be clockwise direction. So I said this is clockwise. You can see this diagram. You can see generally if your watch is there, so the watch needle will move like this, right? So this is a clockwise direction. Reverse is anti-clockwise direction. So thumb is moving downward direction. Current along the current direction you are taking thumb. So the curly fingers, right hand thumb rule. This is my right hand thumb rule you are taking. So thumb is showing downward direction. Curly finger shows the along the magnetic field direction. Along the magnetic field direction. So magnetic field will be clockwise direction. If I am taking the current will be upward direction, the magnetic field will be anti-clockwise direction, magnetic field will be anti-clockwise direction, magnetic field will be anti-clockwise direction, anti-clockwise direction, okay, anti-clockwise direction, anti-clockwise direction, understood? Anti-clockwise direction, anti-clockwise direction. I hope it is very clear to you all. I hope it is very clear to you all. If the current is passing through the downward direction, the magnetic field will be clockwise direction. If the current is moving upward direction, the magnetic field will be anti-clockwise direction, anti-clockwise direction. Very, very important. So in a board exams, they given this question for 3 marks. In the previous board exams, this question. So very, very important. Current carrying conductor. So current carrying side conductor. If the current is passing through the straight conductor, how the magnetic field will be there? So explain with the help of diagram. Explain with the help of diagram means you have to draw. So this is a rheostat. Rheostat is the device which is used to regulate the current without changing the voltage source. Without changing the voltage source, we can regulate the current. Okay. So current is passing from positive terminal to negative terminal. So I am taking here ammeter positive, ammeter negative. So current is moving downward direction. So magnetic field will be clockwise direction. So current is moving upward direction. Magnetic field will be anti-clockwise direction. By using right hand thumb rule, we can identify magnetic field direction. I hope it is very clear to you all regarding the side conductor. Okay, even how to identify the magnetic field, okay, when it is passing, the current is passing upward direction, downward direction, and sometimes, so there are a few questions, so questions will be asked accordingly, okay, clockwise and anti-clockwise also they will ask. At the same time, above the wire, below the wire, suppose I am taking, so there are few questions related to Fleming left hand rule and this one also. At the end, we will discuss few questions related to this concept. Okay. So based on right hand thumb rule, they will ask about magnetic field directional. If the current is moving east to west, north to south, how the magnetic field. They'll mention with the help of north to south, east to west. Okay. So accordingly, we can identify so they will ask in the form of clockwise or anti-clockwise. And clockwise or anti-clockwise. I'll give an example. If the current is passing from north to south, how the direction of the magnetic field will be there? So we can use by using right hand thumb rule, we can identify. I hope it is very clear to you all. So according to that, north to south, east to west, generally with that only, with the help of north to south and east to west only, they will ask questions. Okay, so practice with that, then you will get habitate for understanding the question, for reading the sentences, for okay, habitating with those terms. Okay, what are the terms are there? With those terms, we can get habitate automatically. We can recognize those terms. We can practice those terms, right? Okay, done. Now straight conductor completed. If I take the loop I am considering. So loop I am considering here. This is the loop I am considering. So this question also they will ask in the exam. They will ask also this question. So if the current is passing like this, positive terminal, negative terminal, current is passing like this. Okay. So how the magnetic field will be there? So magnetic field will be more at the center or at the circumstances. The question is, they will ask the question like this. magnetic field will be more at the center or circumstance? More at the center or circumstance. So as you are increasing the magnetic field like this, as keep on increasing the magnetic field here like this, as keep on increasing the magnetic field, as keep on increasing the magnetic field like this. Okay, at the center it will become parallel lines. At the center it will become parallel lines. At the center it will become parallel. So this is north and this is south. Okay, so how it will be if the current is passing, so the magnetic field is moving towards south and reaching, so reaching away from it, that's why it is called north, and reaching towards it is south, that's why it is south. And here it is, I'm taking south, north, north. So here north, here north, here north. Okay, this is north pole and this is north pole and south pole. How can you identify? How can you identify the direction? How can you identify the magnetic field is more? Sir, so is it a uniform magnetic field in the middle? Yeah, that is correct. Uniform magnetic field. Here, at the circumstance, if you are taking at the circumstance, here you are considering here, the magnetic field will be like this. The magnetic field, so keep on, it will be so increasing. When normally, so from this conductor, if you are increasing, keep on increasing, at what end, at certain time, so this will become normal. As I said, the magnetic field bar magnet also, you can see I took the magnetic field lines like this. Okay, at the middle I did the straight lines here also, here like this. Here also same thing. When the magnetic fields keep on moving, so actually the magnetic field will be more near to the conductor. So magnetic field will be more near to the conductor. So when you are moving away from the conductor, the magnetic field becomes straight lines. The magnetic field lines become straight lines. Okay. So here the magnetic field will become straight lines. Here the magnetic field becomes straight lines. The magnetic field becomes straight lines in the middle, at the center. Okay. So what happens? So at the middle, the magnetic field lines will become straight lines. So one magnetic field will be add up to this magnetic field will be add up to this one. So this magnetic field will be add up to this one. This magnetic field. So like that, all the magnetic field will be increases. So will be add up. Then more magnetic field will be there. At the same time, at the center, uniform magnetic field will be there. Yes, Ravya. So is it correct? So yes. So it is correct only. At the center, magnetic field will be uniform. At the center, the magnetic field will be uniform. Because as I said, the magnetic field lines are straight lines. So the magnetic field line becomes straight lines at the middle. Magnetic field lines become straight line. So that's why the uniform magnetic field will be at the center. So than at the circumstances. So the question they will ask, where the magnetic field will be more? Where the magnetic field will be more? At the center or at the circumstances? At the center or circumstances? At the center only magnetic field will be more. So this question they will ask for 3 marks. And 1 mark for, so the magnetic field, where magnetic field will be where? In a circular, in a loop, where the magnetic field will be more? There at the circumstance or at the center? That question they will ask for 1 mark. And this explanation, okay. So the current is passing, so positive terminal, negative terminal, so magnetic field will be created. So when keep on increasing at the center, so the magnetic field lines become parallel, so uniform magnetic field will be created. So one magnetic field will be added to another magnetic field, then the magnetic field will be more at the center than compared to the circumstances. So like this, the questions they will ask. So very important activity at the same time question also. So make sure that you are learning. Okay. So next one. So till now we gone with the a series of magnetic field. One is straight conductor. We took, so straight wire. So around that one we can identify the magnetic field by using right hand thumb rule. So we can identify the magnetic field by using right hand thumb rule. Okay, so right hand thumb rule, by using that one we can identify the magnetic field. And one more point we can consider, loop we consider, at the center only magnetic field will be more. And the next one, if more number of loops if I consider, number of loops I've considered, so loops will be in the form of cylindrical shape. as I said, so loops will be in the form of cylindrical shape. So I'm taking here like this. So I'm taking the loops like this. So a straight wire we are taking, that will be bent in the form of, so are curved in the form of cylindrical shape. Okay, take a straight wire. Take the straight wire, take the straight wire, straight the straight wire, take the straight wire, bent in the form of cylindrical shape, take the straight wire, bent in the or wrap in the form of cylindrical shape, take the straight wire, take the straight wire, wrap in the form of cylindrical shape. So take a straight wire, wrap in the form of cylindrical shape. Okay, connect to the circuit. I connect to the circuit. So you can, if you connect to the circuit, I'm connecting the circuit. Okay. So around this one, anyway, we know if the current is passing through the conductor, it act as a magnet. It act as a magnet. I'm taking here. So positive terminal, negative terminal. So switch I'm taking. Current is passing here. So current is passing like this. Current is passing like this. So as I said, a current carrying conductor act or behave or produce magnetic field around it. How the magnetic field will be there? So with the help of what will we can identify. So normally if you are taking, I already said either you can take 5, 7, 9. Here also you can consider anyone. Okay, I'm taking the 9 lines. As I said, my prefer one is 9 lines. Okay, I'm taking 9 lines. 9 lines. Okay, so 3 lines above. So I'm taking one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 I'm taking. Okay, 3 lines will be above. So here 1, 2 and 3. I'm taking 3. And 3 lines below. So 1, 2 and 3. 3 lines I'm taking like this. And 3 lines will be in middle. 3 lines will be in middle like this I'm taking here. Okay. So current is passing. So one point I will tell. One point I will tell to remember magnetic field. In which direction magnetic field we have to consider. So for remembering sake, I will tell one point. So if the current is passing, that you can say towards that one side. Another side you are taking north pole. Okay. So towards this one magnetic field will be there. Okay, like this. And towards the magnetic field. So like this. So like this towards this one I'm taking magnetic field. Towards the magnetic field I'm taking. Okay. So here towards south I'm taking the direction. So I'm taking the direction. Okay. So along this direction I'm taking in this direction. So here and here. So outside away from the magnet, away from the field. Like this I'm considering. Mm-hmm. Mm-hmm. Actually, this solenoid act as a behaves as a bar magnet. Or the properties of the solenoid, how it will be same as like a bar magnet. Okay. So if the current is passing through the solenoid, behaves as a magnet. It behaves as a magnet. It produces magnetic field. Okay, it exhibit magnetic field around it. So I'm considering here. So this side I'm taking south, this side I'm taking north. So current is passing through it. Okay. So I hope it is very clear to you all. So here next one, the magnetic field. Here in this case, magnetic field can be changed, increased also. Magnetic field we can increase, magnetic field we can decrease, and whenever we want we can magnetize, and whenever we don't want we do so we can remove the magnetic field. Okay, so here I'm considering the difference between bar magnet and magnetic field. Bar magnet and magnetic field, this question they will ask for 3 marks. 3 marks. Bar magnet and magnetic field. Bar magnet and solenoid. Bar magnet and solenoid. Bar magnet and solenoid. Okay, first one I'm considering. First one is about here. Bar magnetic field is fixed. Magnetic field is fixed. So I'm taking this bar magnet north to south. Okay, so the magnetic field will be like this. So here the bar magnetic field is fixed. Magnetic field is fixed. Magnetic field is fixed. Okay, here magnetic field is not fixed. Magnetic field is not fixed. Okay, so here second one, coming to the second one, here strength of the magnetic field is same. Yes, Rabia, correct only. So that all I am discussing. Here. So if number of field, if number of turns decreases, magnetic field also decreases, and depends. See, solenoid magnetic field depends on number of turns and also the gap. Okay, the gap. How much gap? If gap is increases, automatically magnetic field also increases. So if you are taking one turn to another turn, the gap is there, right? So when you are wrapping, if gap is more, magnetic field also more. If your gap is less, magnetic field within that region only it will be there. So magnet will be more. So more area it will attract the magnetic materials. And also strength. If I'm taking 3 cells, if you take 4 cells, 5 cells, 6 cells, if you take number of cells, accordingly magnetic field also increases. So solenoid magnetic field depends on strength of the current and the number of turns. Strength of the current and number of turns. It depends on strength of current and number of turns. Okay. Magnetic field of solenoid depends on strength of current and magnetic field. Okay. So bar magnetic field is fixed. Okay. The pole strength also fixed. We can't increase the magnetic field. We can't decrease the magnetic field. But here in solenoid magnetic field we can increases by changing the battery. So if you add more cells, okay, if the strength increases, automatically magnetic field increases. And also number of turns if increases or decreases, accordingly magnetic field changes. But here it is fixed only. Okay, so it is artificial magnet. Okay, this is one here. Whenever we can, if you want to magnetize, we can add the battery. If you don't magnetism, we can remove the battery. But here, so that we can't change anything. Magnetic field of bar magnet, we can't change anything. So whatever you do, so the magnetic field will be there. Maybe if you heat and if you like that, so that time magnetic field may reduce, but normally the magnetic will not change, right? So magnetic will not change. But here we can magnetize, we can demagnetize also. If you remove the battery, demagnetize. If you add the battery, magnetize. That's enough. Okay. So this is about bar magnet and solenoid. So the difference between bar magnet and solenoid. I hope it is very clear to you all. Next one we are going to the one more condition. So that is about current carrying conductor placed in the magnetic field, and using Fleming left hand rule we can identify the force acting on the conductor. So the last concept. So we'll discuss this concept and we'll wind up. Okay, so we'll see. A current carrying conductor placed in the magnetic field experience the force. So this point is very important. This question, difference between bar magnet and magnetic field. So they will ask for 3 marks question, bar magnet and magnetic field. And the next whatever I'm explaining that question, they will ask for 5 marks. Okay, that question. Now I'm going to explain about current carrying conductor placed in the magnetic field experience the force. Electromagnet. So in industrial purpose and also in hospitals, actually in industrial, so there are heavy metals. Ramlakshmi, hi. Welcome to the class. So just you will come and say hi and leave the class. Okay. Anyway, hi. So come to the class. So here I am considering electromagnet uses of electromagnets actually in industrial purpose to lift the heavy metal sheets from one place to another place. Okay, and there are many uses electromagnet even in hospitals also. In hospitals also to remove the whatever the materials are insected. If the accident happens, small iron particles will be there in our body. We can remove by using electromagnet only. And we can see the bell also, electrical bell is there, right? So if you on switch, automatically current will pass, so magnet will be created, automatically it will hit. So by that only electromagnet bell. Okay, so that, and like that there are many applications. So one is industrial purpose, hospitals will use especially. Okay, so these are the uses. Next one, coming to the current carrying conductor placed in the magnetic field. So if the current is passing through that from A to B, so current is passing like this, current is passing like this. Okay, here I already said, if the current is passing through the conductor, if the current is passing through the conductor, as I said, if the current is passing through the conductor, okay. So next, if you are taking here, next if you are considering here, okay, when the current is passing, as I said, if the current is passing through the conductor, 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 conductor act as a magnet. Conductor exhibit a magnetic field, and it shows magnetic field. Okay, surround it. As I said, if the current is passing the conductor, if the current is passing through the conductor, this aluminum rod, what I'm taking, this aluminum rod AB. So when the current is passing through that one, it acts as a magnet. So that magnet we are placed in the external magnetic field. So as I said, the horseshoe magnet, U-shaped magnet, U-shaped magnet. So we'll have, if you see, actually the magnet will be like this U-shaped magnet. Like this it will be there. One side is north, one side is south, one side is north and one side is south. Only at these poles the magnetic field will be more. Okay, so that is placed here, that is placed here. So current carrying conductor placed in the magnetic field, this actually here this U-shaped magnet is fixed. Whatever I am placing, this U-shaped magnet is fixed. Okay, so this is fixed. This we can it can move. Okay, so conductor will move because force acting on the conductor. So conductor will move. In which direction the conductor will move? That is the question. In which direction the conductor will move? So here current is passing, magnetic field. Magnetic field is fixed. Anyway, magnetic field will move. So magnetic will move from north to south. Anyway, that we know. By using Fleming left hand rule, by using Fleming left hand rule, we can understand. So here you can observe one thing. Fleming left hand rule. So left index finger shows the magnetic field. Index finger shows the magnetic field. So middle finger shows the current direction, and thumb shows the force acting on the conductor. Mother, father, child. Mother, father, child. Mother, magnetic field. Father, force. Child is the current. Mother, father, child. Mother, father, child. Once again, mother, magnetic field, fixed. Okay, so we know that magnetic field. North, south, current is. So current we know. Okay, so mother we know, child also we know. Then automatically in which direction the father, force will be there, force acting on the conductor we can identify. So by using Fleming left hand rule, we can identify. Okay, so index finger shows the magnetic field, middle finger shows the current direction, and the thumb shows the force acting on the conductor. 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 So now you see direction of magnetic field, current direction. So inward, okay, into the board. The force acting on the conductor into the board. Okay, this is about current carrying conductor placed in the magnetic field. Experience the force. By using Fleming left hand rule, we can identify the force acting on the conductor. So I hope it is very clear. So this is about current carrying conductor placed in the external magnetic field. Experience the force. By using Fleming left hand rule, we can identify the force acting on the conductor. So next one now, short circuit overloading, all we discussed. Yes, so that's enough. Maximum short circuit overloading. So those also in electricity, but still we will discuss those points also. Okay, so I hope it is very clear to you all. So if you have any doubts, you can reach me regarding the doubts and the explanation of any topic. So any doubts related to CBSE grade 10 physics, you can contact to this number. So 984981280, 984981280. If you need any classes regarding not only physics, if you need biology, social, English, maths, and remaining subjects also, if you want, so you can contact to me through that number. I had a great team. People will be there. Faculty members are there in my team. Okay, so they will guide you in a right way. They will teach the concepts in the best possible way to reach you out. Okay, so if you have any doubts, you can reach me out. Okay, so that is my phone number. This is your Siva sir from Student Brand. Thank you so much for joining and attending and interacting with me. Signing off. Namaste.